going to talk about our journey, continuing from our last year talk. It's about coding principles. So we come up with 9 coding principles at iPrice. Why is this important to us, and where did the journey start? So before we get there, ooh, it doesn't work.
Down.
Down? Okay. Oop, down. It doesn't work.
Wait. Technical glitch.
You're so anti-mainstream. Why are you using Google Slides?
You told me to use it, you know? It's not loading anymore. Your Wi-Fi.
Is it? No?
Yeah, we're using his hotspot, and then he went far away, so...
Okay. Cool. The Golden Gate Bridge. It's one of the best man-made bridge. It's a suspension bridge. At that time, it was really grand. And the Golden Gate Bridge was actually a really successful project because not only it was ahead of schedule, it was also under budget. But there is a problem. Even though the delivery was really fast, even though it was ahead of schedule and under budget, 11 workers was actually died during the 4 years construction. So they came up with this solution. They put a safety net under the bridge. Even though 11 people died, there was 19 people who were saved. They were saved by these safety net. So what we learned from this story is if you want to go fast, you have to have a safety net. So last year, I was talking about how at iPrice, we just scrap out deadlines. So our product managers, our CEO, they don't just come to developers with arbitrary deadlines. Because deadlines is, a lot of deadlines are just arbitrary. People just come up with deadlines without really knowing why does the date really matters. But we hit a problem because we went really fast, and there's a problem at technical level that's actually slowing us down. So there was a lot of technical debt inside our system, and the technical debt is actually slowing us down. It's actually impeding our agility. So how do we know that we created a lot of technical debt? So we use this really simple metric, and Sandy is a developer. He's going to share insight from developers' perspective. So the easiest metric to measure if your code has a lot of technical debt is measure how many what the fuck per minute developers mention every time they look at the code. So there was a lot of what the fuck per minute in our developers. They just literally hate the code. They get sick of the code. So we know we have to change. So we come up with this conclusion to go fast is oftentimes you have to slow down. And we like this picture. It tells us a lot. So a lot of times in the software developers, in the process, well, it's not necessarily the software developers' problem or it's their mistake, but a lot of time from the business, they keep on pushing for features, and there's no time for software developers to stop and think and have a retrospective to continuously improve, whether that is their process or even their code. So the lesson here is to go fast is actually to slow down. And we need a safety net in our code so that we can go faster and faster, because without the safety net, we will be really afraid to touch the code. How many times you've been in a situation, oh, don't touch that code. If you touch that code, it's going to create a defect somewhere else. So to have confidence, the developers need a safety net, so anything they change is not going to create defects or depth anywhere else. And you are going to talk
I think I'm going to
this.
just stay here and look at the slides. So, a lot of developers they're so proud of solid and Gang of Four design patterns that they know this and they're cool and stuff. But this principles or solid principles or design patterns requires prior knowledge in object-oriented design, so you don't mess up the code even more, because if you use the patterns, sometimes the developers modify the problem so it fits a pattern, and actually that's worse than not having a pattern at all. So what we come up is we studied this grasp, which is so solid is the destination of how your code should be like. So it's like a structure of a proper structure, and then grasp is how to get there. Grasp has 9 principles, which are this: creator, information expert, low coupling, controller, high cohesion, indirection, polymorphism, and protected variation.
And
Pure fabrication. Yes, thanks. So let's have a simple use case. We can apply the grasp principles. 1, creator. It asks the questions, who should be responsible for creating an instance of some class? So actually this is who should be responsible, which class should be responsible for triggering the new keyword in object-oriented programming. You don't just put this, use this keyword anywhere. There's the guide on how to create instances. So assign class B the responsibility to create an instance of class A. If one of this is true, the more the better. If B contains or compositely aggregates A, B records A, B closely uses A, or B has initializing data for A. So let's look at the partial domain model again for the simple checkout we have. We have order. So the problem is who creates the line items. Since order contains line item, then order should be responsible for creating the line item. But sometimes, again, the creation of an object requires some complexity. So that's the motivation behind the factories you have, like factory patterns. All right? Next is information expert. What basic principle by which to assign responsibilities to objects? Where do you put a method? Which class do you put a method? Answer is simple. Assign the responsibility to a class that has the information needed to fulfill it. But again, the partial domain model, let's have the problem of how do we get the total of an order? Now, since first we determine what data we need to get the total of the order, we need the subtotal and the subtotal of each line item, and then subtotal of line item is the product of the quantity of the line item and the price of the product associated to it. So, since order has the data, because it knows its line items, we should put that responsibility there. Sometimes a lot of developers do create another object to store, to read from the order, for example. It's like an arbitrary class that calculates the grand total when it doesn't really need to create that class. So that's a common problem with these design patterns are solid, because we want to have single responsibility. So the responsibility of this class is just to calculate the total of the order. It's lazy. It's creating a lazy class. So in here, the person here or the client executes a get total message to the order, and then the order executes the get subtotal from the line item, and then the line item executes a get price from the product. That means these three classes now are partial domain information expert for getting the total. So they collaborate to get the total. Next, the controller. What first object beyond the UI layer receives and coordinates or controls the system operation, or in HTTP is a request. Controller assign the responsibility to a class representing one of the following choices. Represents the overall system, a root object, a device that the software is running within, or a major subsystem. It's called the facade controller. Or it represents a use case scenario within which a system event occurs. It's called the use case scenario. So the thing is, in HTTP, especially in PHP developers, they put business logic in HTTP controllers. And HTTP controllers should not have business logic because it represents the HTTP. And HTTP is your input-output to your system. It's your I/O, and it's part of the UI layer. It shouldn't have the responsibility of, for example, calculating the total. It should only take care of the HTTP stuff, like sending 404, for example, those status codes or headers and all those stuff. So in here, the controller here is the one that coordinates the system objects. Example of facade controller is, let's say your system operations our simple checkout order has create order and make payment. An example of facade controller is you create your subsystem or the system that represents the system, and then put the system operations there. Like here in checkout has create order and make payment. So your checkout there is the actual controller, not your HTTP controller. Or you can use a use case controller where you break the order, you break these methods into their own classes. The benefit of this is if you have other responsibilities for the order, you can just add it there. So the cohesion will stay high. Cohesion, I'm going to discuss that later. Next, low coupling. This is pretty common. How to support low dependency, low change impact, and increase reuse. Answer, assign responsibility so that coupling remains low. Use this principle to evaluate alternatives. So this is an evaluative principle. So when you are designing your system, you need to always evaluate your design so that it doesn't suck. Like the trend of the design doesn't go to a place where it causes problems. So you use a low coupling and high cohesion for that. So for example here, how do we create a payment for an order given this object? So you have a payment, which is the one you're going to create, and then you have the checkout, which is your controller, and then you have the order. We can use, let's look at design one. In design one, the checkout, which is the controller, creates the payment and then associates that payment to the order. Now the problem with this is, you see how many lines are connected in the checkout? That's the coupling. So checkout can see the payment even if it doesn't need to. Because at the end, the payment will be associated to the order anyway. So why not do this? Ask the order to create the payment itself. And then, since at the end, eventually, the payment will be associated to the order class, you don't need to have to check out to create the payment object and associate to the order. So this is the example of low coupling. You only have one line per object. But, again, this is subjective. It doesn't have to be always one line because systems are complex. And low coupling, the coupling cannot be avoided because we're actually creating a system of coordinating objects. But low coupling advises us to not make or to evaluate our design so that it doesn't increase the coupling in a way that would cause problems in the future. Okay. High cohesion, how to keep objects focused, understandable, and manageable? Answer. Okay. Assign responsibility that cohesion remains high. Use this evaluative principle as authoritative. Again, this is evaluative principle. We go back to the payment checkout order. Design one is, it sucks because checkout participates in creation of payment when it doesn't need to. Because checkout is a controller, it should only coordinate the objects. Since checkout is not sending any message to payment, it doesn't need to see it. Then we go to design two again. This supports high cohesion because checkout is just coordinating the order, and then order creates the payment and associates it to itself.
Look at the slides there rather than
Okay. For polymorphism, how to handle alternatives based on types, how to create pluggable software components. When alternatives or behaviors vary by type, class, assign responsibility to the behavior, blah, blah, blah. So this is pretty common, where you have a case statement, and then you have different logic per case statement. What polymorphism says is to create classes for each varying behavior and then assign the same name, polymorphic operation, that's called polymorphic operation, the same name to those classes, and then, so in here, order just sends the get discount to the discount calculator, regardless of how the discount calculator was configured in the system. Pure fabrication. What objects should have the responsibility when you do not want to violate high cohesion, low coupling, or other goals, but solutions offered by the previous information expert are not appropriate? Wi-Fi. Ooh. No, it needs Wi-Fi. Sorry, guys. Okay, assign highly cohesive set of responsibilities on artificial or convenience class that does not represent a problem domain, some concept, something made up to support high cohesion, low coupling, and reuse. So, again, the problem with arbitrarily creating classes without any reason at all, this gives you the motivation to actually create the classes. For example, you have the order. You have grand total and then formatted grand total. And then you have the get created at and then the formatted created at. So in here, the order is getting burdened by a lot of methods that it shouldn't even care about. But since, by the principle of information expert, we should put these methods in the order because the order knows its data. But then, if you look at the trend of the order class, it's getting big and incohesive. So how do we, oops.
Next.
Yep.
Okay.
What happened here? Okay. So what we did here is we extracted the behavioral stuff and then created a class from it. What's that? Okay. And then assign those formatting stuff there. That way, we maintain cohesion in the order. It only takes care of the data, but not the formatting. Again, indirection. Where to assign responsibility to avoid direct coupling between two or more things. How to decouple objects so that low coupling is supported and reuse potential remains higher. Assign the responsibility to an intermediate object to mediate between components or services so that they are not directly coupled. So let's look at the make payment scenario again. Let's say we need to log the payment somewhere and send analytics somewhere. In this scenario, order is being burdened by the knowledge of logger and the analytics.
Look at the audio.
Mm-hmm. He's giving me tips. This is my first time to talk. So, yeah. So in here, in the first image, the order is pointing to two objects, which lowers its cohesion because it doesn't really need to take care about those logging or analytics. And then what we did is we created an order probe to mediate between the order and the logger and analytics. Some people would use PubSub or event dispatch for this, but I prefer the probe because it's more clear. It doesn't get you blind on which subscriber are subscribed to an event. Okay, let's going back. Make payment, blah, 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 blah. But in here, in the second image, the order is still a bit incohesive because it needs to call on the order probe when it doesn't really need to care about that. It just wants to they want to deal with the order stuff. Now, the last image is a better one. So we extend a probed order from the order and then have that take care of the order probe stuff, presenting to log and analytics. This way, we increase the cohesion of the order. Order now doesn't need the order probe to send the analytics, and then we increase the focus of the cohesion of order probe. Probed order, I mean. Protected variation, how to design objects, subsystem, and system level variation and stability, LMS, don't have an undesirable impact on other elements. Identify points of predicted variation or stability, assign responsibilities to create stable interface around them. So points of variation. These are the already predicted variations in the system. For example, the discount calculator I presented earlier. And also you remember the get subtotal? It's also a point of variation because let's say we change the data and then the data now doesn't calculate by the product price. Let's say we added the sale price and then use that instead. If we didn't use the get subtotal, then the order will need to know that, oh, we changed the data and we need to change the code of the order instead of protecting it in the get subtotal. And then evolution point, speculative points of variation that may arise in the future. Like different data, that's what I already mentioned, data sources or user interfaces. Like for example, for now you're using SQL, and then when you scale up, you figure out that SQL is not that scalable, not fast enough for your needs, and then you change to Elasticsearch. So you need to predict this kind of changes. So this is coming from the business layer, protected from the UI layer and the infrastructure layer. Oops. It's working now.
No, you tell this.
Benefit.
I thought you can tell.
No,
Yeah, so the benefit of GRASS we found in the field is it's easier to teach to developers. Let's face it. It's not hard. It's very hard to get good talent. So if it's hard to find good talent, then why not just create it? Teaching them design patterns or solid is, I think that's a next level, but not really. So the fundamentals are here in GRASP, and actually this mindset itself is already very good, has very profound impact in the code base when the developers knows it.
Oops. Okay. This was a recent news. 7-Eleven have to kill its product, the 7Pay, because it got too much technical debt on security level. So what we're trying to convey, the message here, you have to connect the technical metrics to the business metrics. You don't want to end up like this. your code, your application have too much depth, then you have to kill your product. That's such a waste. So we connect technical metrics at iPrice to the business metrics. So as we said, we found a lot of technical depths, a lot of defects rate, a lot of production incident rate. So we connect that to the time to market. It's slowing us down, so we're not able to go to the market really quick. And we can visibly see that our lead time, our cycle time, our deployment rate to production is getting lower and lower. And if those technical metrics, the ones underneath, is really bad, then we can see how it's impacting the business. So the top is the business metrics, and the bottom is the technical metrics. So if we're really fast, if we're really agile, then we should be able to get to the market faster. If we can expand our business, if we can get more value from the market, then we can invest more in the untouchable realm. So we can invest more in a market that's not really touched yet. And from there, we can invest more in innovation. So the point is, do not underestimate technical depth, because it can really impact your business and connect the technical metrics with the business metric. That is all from us. Thank you for listening.